Welcome. Today we'll learn about the second most important and simple data sorting algorithm that is named as selection sort. This is also most commonly used for small data sets. This is not recommended to use the selection sort algorithm for sorting purpose for the large data set. Its comparison and swaps are much more similar in best and average case to the bubble sort, but this also provide efficient performance in worst cases. Because bubble sort worst case performance required n square swaps and the selection sort worst case required only n swaps. Before going to the practical implementation and demonstration using C++, we have an animation or application that is developed and designed by binary visuals for demonstration of selection sort. It has various options. We can see here these are insert values in the data set. We have to clear the data, random seed, random insertion, sort, order, ascending or descending. We can quickly sort using selection sort using this application, or we can also simulate our process. This simulation process also have different or various options that can be very slow, fast, or etc. This is the basically explanation of the application that we are going to use for the animation process of the selection sort for better understanding. So let's start using the random seed option of this application, and we are using here ascending order, and we are going to sort not the quickly using simulate sort, and we are going to start the simulation of the selection sort. In this simulation, we have to check or we have to monitor the clear idea of the selection sort. First of all, it will find out the minimum or maximum value from the entire data set. It normally divides the entire data set or array into two different parts. One part is that it contains the sorted array or data set, and the other part, remaining part, contains the unsorted data values. It gradually enlarge or increase the sorted data set volume, and at last the entire data set will be the sorted form. We can see here, if you are engaged with our video session, you can see in the simulation what is going on. It first of all select here is the explanation of the elements, how these are colored in this simulation. First of all, this is the sorted list or sorted items that is colored as green. And what is the next? Why this is colored as yellow? This is the element to be sorted. This is the prior element in the unsorted list that will be go to the sort in from the unsorted data. What is going on here? It first of all select an element from the unsorted list to whom it have to sort out, and the remaining part of the list, unsorted list, is checked out for better swap option to the selected element. This element will be called min, named as min identifier in our algorithm or implementation that will go very soon in this video session using dev C++. You can clearly see here this indicate the element to swap indexed by 2. Here is written indexed by 2, indexed by 3, etc. Various options are used here. We have to check it first option for the better understanding. We can see here this option is going very fast. Okay, yes. Oh, looks like better. We can see here the simulation. The array is sorted using the selection sort. I have to do it again. First of all, I have to stop random seed. I have to simulate it. Now take a look just a while for 15 seconds to 20 seconds to take a look on this sorting algorithm technique, how this is sorting the entire data set. I have to again set this random seed so that we have no any kind of trouble with while implementation of this selection sort using dev C++. You can see here the selected element is colored as yellow, to whom we have to swap with from the unsorted list of array elements, and this yellow is the part of the unsorted data set, and this is normally the starting index or first index of the unsorted data list. Okay, observe it and keep it in mind that it will be the first element in the unsorted list. Okay, so let's start by creating a new project using dev C++ before wasting any time more. Okay, create a new project using new option, new project. Click on console application, write here name, selection sort. I have named shortly SS for the selection sort. Click on OK. Save the project, save again, press Ctrl+S again to save the file named as SS. These are the default line of code written already in each and every dev C++ project. We are naming here using namespace. For using the standard C in cout object, we have to write down here using namespace. You can also check out namespaces, how these namespaces work in C++ in our video session that is available on our YouTube channel. I am going to write down here a method that is named as selection sort, that will be called later on in the main function. I am getting the array as the parameter and size of array. We can also compute the size of array in the function, but for the time being I am writing here as the parameter. These parameters are called formal parameters. About this is also YouTube lecture is given on our YouTube channel. What are the actual and formal parameters? In selection sort method, I am going here to introduce two variables named as I and j. These variables are also called counter variables, and in next line I am declaring a variable that is called min. This is basically min. What is min variable? This min variable is basically used to contain the address or index of the element who's to be swapped in the list. Okay, after this I am writing down the simple for loop that is I is equal to 0 start from starting index, and I will go through I is less than n minus 1. Why I am going to n minus 1? Why I am not going to I is less than n? Because the last or nth element is also sorted or already sorted, so that we have to not worry about this, or we have to not waste our one iteration for checking either the last element is sorted or unsorted, because we have a clear knowledge that the last element will absolutely sorted in proper order. Okay, I plus plus. This is the outer loop, and in outer loop we have to set down the min position. As in visuals we can see here, I have to again random seed. This is the min position. I have already told you that starting index of the unsorted array element, the start or first element, will be the element who's to be swapped out. Here is the I is the min location. Here we will write down the second loop that will start I j is equal to I plus 1. Why I am writing here I plus 1? Why I am not writing here j is equal to 0, j is less than blah blah blah? Because we know that the selection sort is about to divide entire data set into two parts, and here we can monitor that in the practical demonstration or animation. We cannot use as from the starting index, because here we can see that the starting index is sorted out. As we will go through the I, we have to set down j from the ith position. Okay, now move to our code. This will be the incremented I. What will be the I in a loop? Ith element will be the last element of the sorted array. Okay, we have to move from one element upward from the sorted array. Here we will write down j is less than n. We have to move until the next element to check out for the swapping. Why we are not writing here n minus 1? Because there will be the last element who's to be swapped with the selected pivot or minimum element. Here we will write down j plus plus, and in this situation, in this inner loop, we have to compare the adjacent or comparing the pivot minimum element with the corresponding list of the each and every individual element of the unsorted array. So here we will write down or j is less than a or min. Then what we will go on, we will just have to write down. We can also place a parenthesis or avoid this parenthesis because there is a single statement. We have to set down it as I. Oh, sorry, this is set down as j. Okay, what is going on here? In this, we are checking either the coming jth element of the unsorted array is less than of the selected element. If this will true, then the selected element will be the chain to swap in with the unsorted list. And after this loop iteration, after this entire loop, we have to swap the ith index with the min index. We will write here temp. Temp is a variable that is required to swap the elements. We will write here temp is equal to ar min. We have to swap ar min and ith element, that is the ith element is the first element of unsorted data set, and min element is the element that we have selected from the unsorted data set to be swapped from the first element of the unsorted data set. Okay, ar min is equal to ARI. Here one delimiter is, and here we have to place AR min, and ARI is equal to temp. ARI is equal to temp. There is not temp variable is declared, so we have to declare temp variable. So nice. This is the complete sorting method using the selection sort is done here. Okay, let's move it again. We have to declare an array inside the main function to check this sorting method using the selection sort. We are declaring here array that is called int ARR, which will contain the elements. Random element we can place here. Let's suppose 97, 55, 1, 2, 98, 33, 67, 17 and 49. You can change these elements according to your requirement, or data set may be varied. We are also declaring here a counter variable that is named as I to control the iteration for printing the data before and after sorted array. Here I am getting the size of the array in n variable, that will the equivalent to size of complete array divided by the any one single element of the array, size of a or 0. Okay, after this I am going to print the array that will be the equivalent to I0, I is less than n, and I plus plus. After this I am writing down the lines cout ARI and putting here some kind of space for the beautification. After this iteration I will use the endl manipulator to returning the new line. Here I will copy the code and paste it again. I am displaying the message cout unsorted array. After this message I am placing endl manipulator, copy these line of codes before call of the selection sort method, paste here. Then I will, after calling the selection sort method, write here sorted array. Again we will print the array. We are calling here the selection sort method. Selection sort passing here array and its size. So now we will have to check the code. Either here will maybe any kind of error, we have to remove this. Okay, compile the code. The code is compiled successfully, and you can see the sorted and unsorted array data is presented in our output. This is the data that is provided to the selection sort algorithm or method we have write down in C++, and after the calling of the selection sort method, it returns the sorted meta, or it sort out the data values provided in the array. This is basically working, and actual algorithm of the selection sort, I have to clear the idea once again using the line of codes. What is going here in the module in the entire line? First of all, I have write down the selection sort method name and take two parameters as array name and size of the array. We can also calculate size of the array inside method selection sort. For the timing, we take it as the formal parameter in the method. After that, we created two variables declared I and j for the counting purpose for inner and outer loop. After this, we specified here the min variable we named as min index or min or pivot, etc. That will the element from the unsorted. I have repeat this sentence in the entire video session. This is the element from the unsorted list, and this is the starting element, starting index from the unsorted list, that we will have to swap the from remaining part of the unsorted list. Which will be the swapped in, and then after swapping this from the unsorted array, remaining unsorted array, it will become the part, this min index will become the part of the sorted array. We can see here in the outer loop, this start from the starting index 0 and goes up to the n-1. In outer loop, we assign this min as 0, means the first index of the array. Same sentence will be repeated again. This is the starting index from the unsorted, because initially the entire array is in unsorted form. So for the time and time, the inner iterations will go through the from I plus 1. Why here we will write here I, why? Because the selection sort divide entire data set or array into two parts, unsorted and sorted. The ith element or the outer loop will justify the sorted data set up to the ith value. In inner loop, we will find out either the elements are in proper position. We have to check each and every individual using the iteration, inner iteration by the pivot or min element. If any other element is less than or greater than the min element, then we will change it by using j. For initially it is I from the outer loop, then it can be changed in the jth. After this process, we have to swap these min and ith element from the min. Min may be I itself, or maybe change to j using this formula for the better order, better arrangement or in ascending or descending order. That we will have also seen in the demonstration. We again random seed at the last of the lecture. Random seed, we are going to take a look at the process entire strategy or algorithm of the selection sort. I am getting it very fast, so the lecture will be completely fast and you will get it and take a practice using dev C++. So nice of this lecture or this session. I have repeated some sentence again and again for the sake to have better understanding and remembrance how selection sort works. So nice. Keep watching and touch. Subscribe our channel and touch in with our channel for latest update and latest algorithms and designing and techniques using Visual Basic and C++. Okay.